So this one says, what is a quadratic polynomial function with zeros 3 and negative 3? And then B is, what is a cubic polynomial function? We're adding a third zero there, which makes sense because it's cubic. 3, 3, and negative 3. And then graph the function so we can see what are the differences, what's the same, all of that good stuff. So for 3a, we want a quadratic with zeros of 3 and negative 3. So we still have to think, where did that come from? You know, what did the linear factor look like that gave me that? Well, if it's 3, that came from x minus 3. And if it's negative 3, that came from x plus 3. And we need to see that as a polynomial function. So we would just multiply that together and say that's x squared minus 9. Well, that's not tough to see. So in C, they want us to graph this. And I realize, well, this is just our parent function down 9. So all I have to do is start my graph at 0, negative 9. But think of it as having the exact same width as our normal quadratic. So that means from here I would go up 1 and over 1 to get another point. I'm going to move that up so people can see that. And then back to the start, I would need to go over 2 and up 4 to get another one. And back from the start, I could go over 3 and up 9 to get a third point. I could use symmetry to go in the opposite direction. Easy enough to graph there. Or you could punch it in your graphing calculator and use your local min or your table to see where that's going to go. So there's our quadratic. Definitely crosses at those zeros, those 2 spots that we talked about. And then B says now we're going to have ourselves a cubic. So if it's 3, 3, and negative 3, that came from, I'll call this one g of x. Even though I have a different color up here, better to have a different name for this one. And that would be x minus 3 and x minus 3. And then x plus 3. And like I talked about when I was going through the homework, you look for something that's going to be a nice pattern that's going to eliminate some work for you. And so for this one, I definitely would go after these back 2 first. Knowing that that's a sum and difference pattern tells me I'm just going to get 2 terms out of that, and that'll make my life a little bit faster and easier. So g of x equals x minus 3, and then this would be x squared minus 9, which we just did that math a minute ago, so of course we know that. And then we can do some FOIL. So first times first would give us x to the third. And I'm actually going to do FILE this time. And that's because I want to keep these in order if I can. So if I did the outside times outside, I'd have the x term next. I don't want to do that. I want the x squared. So negative 3x squared minus 9x plus 27. There it is. Now, we know the zeros. It said 3 is a 0 twice. And then we have negative 3. So the same zeros that we had over here for our quadratic, but this one is a cubic. So I'm going to put on here what I do know before I grab a calculator, and what I do know is this is a positive leading coefficient, so that means my end behavior here is down and here is up. Because remember, you can get this little visual in your head of a cubic with a positive leading coefficient. Now, I do know more than that, but we're not supposed to know more than that just yet. So what we would do is we'd grab the calculator and we would punch this in. So, x cubed minus 3x squared minus 9x plus 27. looks like so. Now, I start thinking, do I even have to change the window, or do I know what's going to be happening with this graph? And here's what I know just looking at it. If I put a 0 in here, 0, 0, 0, and 27 is going to show up. So that means my y-intercept is at 27. So I can't go by 1s, or I'm not going to fit it on here. Maybe I go by 3s. And I get that 0, 27 on there. 3, 6, 9, 12, 15, 18, 21, 24, 27. And then I should really see, is that the highest point? Maybe there's something a little higher up there. So I can go back to my window and change that y value to 27 and hope that that will be the highest point. It's not. So I might still be going off a little bit. Let's see if we can check like 36 here. So the highest point is just a little bit higher than that 27, but we want to know where it is. And that's where we hit second trace. And that position is called a local maximum. It's not the maximum on the whole graph. You know, we know this is going up forever. But it is a local maximum, and that would be number 4. And we need Blinky on the left side of the hill because that's what he's asking us for. That's his prompt, left bound. And we need Blinky on the right side of the hill. Just enter your guess. And it happens to be 32. So it's going to be just a little bit off of our graph. So our max of 32 at x equals about -1. So this same and different stuff again. They have the same zeros, but different behavior, especially end behavior, because this is a quadratic and this is a cubic. But I'm wondering if there isn't some way for me to know about this, you know, that it just bounced right there at 3. So I look back at the information that we had to start with, and I notice, hey, that was there twice. So maybe, just maybe, that's how I'm supposed to know whether or not they're bouncers or not. You know, maybe if they show up twice or an even number of times, then they're going to be bouncing off instead of cutting through. And that's the next thing we're going to study. So problem 3 says, we could write f of x equals x plus 2, x minus 2, and x minus 3 as x plus 2 squared, x minus 2, x minus 3 for the second one, depending on, you know, which graph we're looking at. And this is actually going back to the one that we did in class yesterday for problem 3. Now, because in g of x, the x plus 2 factor makes -2 a repeat 0, or called a multiple 0, that's why that bounces, because it's a repeat. So we're supposed to now add that to everything we already know. We have the zeros, we have the end behavior, we can do things like put a 0 in and find the y-intercept, but now we're also going to know whether or not it's going to bounce or not. So because -2 occurs twice, we can say that -2 has a multiplicity of 2. And a 0 of multiplicity n means that that linear factor x minus a appears as a factor n times. So let's go back to this for a second, because sometimes they get so caught up in their language and new vocabulary use that people say, what on earth are they talking about? So if I go back to g of x, and I see that x minus 3 is there twice, that tells me that 3 as a 0 had a multiplicity of 2. -3, we wouldn't say that has a multiplicity because it's only there once, and it doesn't make sense to say that something has a multiplicity when it's only there once. But whenever we see something multiple times, that's when we give it a multiplicity. And this is usually how we write it. We don't write out the word multiplicity every time we want to talk about it in math. 3 has a multiplicity of 2. So we've got a box down here that says how multiple zeros affect a graph. So this is going to tell us how do we know whether or not it's going to cut through it and just be a normal x-intercept, or if it's going to bounce. If a is a 0 of multiplicity n in a polynomial function y equals p of x, then the behavior of the graph at the x-intercept a will be close to linear if n equals 1. Close to linear. That means a line. So that means if we have multiplicity 1, 3, 5, 7, etc., and I know the book doesn't go this far for you guys just yet, that our graph is going to cross at that point. So wherever we see a factor and we see, wait a minute, it's only there once. Oh, it's there 3 times. Our graph is going to cross at that x-intercept. But close to quadratic if we get n equals 2. Close to cubic if n equals 3, and so on. So what they're really explaining is that if we see an odd multiplicity, it's going to cut across. If we see a multiplicity that's even, then it's going to bounce. It's going to be tangent. Would be the fancy math word for that, but really we can think of that as bouncing off. So now we're going to have the zeros. We're going to have the end behavior. We're going to know what's happening at the zeros. We're almost going to have these graphs done just by looking at the math behind them. The one thing we just still can't do is that local max and that local min. Have to wait for calculus for that. The rest of it we can get, which makes a pretty good visual in our head of what a polynomial is doing when we're going through these. So this says, finding the multiplicity of a 0. What are the zeros of this mess, and what are their multiplicities? And then how does the graph behave at those zeros? So that would mean we're supposed to be able to factor this bugger. All right, I've been going through the list with you again. So what do you see that we should do first? Yep. Take out that greatest common factor. What do we check for next? Perfect squares. Not a perfect square trinomial, right? Not -8 in the back, not going to happen. Doesn't mean it isn't factorable though. So do we have two numbers that multiply to -8 and add to -2? What are they? -4 and 2. So far this isn't any different than anything we've done before. So now what we're going to do is we're going to find the zeros. And remember, wherever there's an x, there's an answer. What answer is that responsible for? 0. Now here's the really important part of this, the new piece. It's squared. That's a multiplicity 2. So is it going to cross at that spot, or is it going to bounce? It's going to bounce. So now we know we've got a bouncer. What's this x minus 4 giving me? 4, 0. Again, I don't say it has a multiplicity, but just so you have this to look at in your notes, let's write M1. So is that going to be a crosser or a bouncer? It's a crosser. How about x plus 2? What do we get from that? And again, we'll just put M1 in your notes so you can see that. Crosser or bouncer? Crosser. All right. Let's make the graph. 0, 0, 4, 0, and negative 2, 0. It was a quartic, and it has a positive leading coefficient. Remember, that means the end behavior is going to look like this. We know it's going to bounce at 0, 0. And we know it's going to cross at these 2 points. So I know it's going to do something like that. What I can't know is just how far it's going to go down without calculus. That's just the one thing I can't do. But we can certainly grab a graphic calculator and make sure the rest of the stuff is right. Again, because I'm recording, I should do it on this one. Alrighty, so we had our little quartic of x to the 4th. Minus 2x cubed. Minus 8x squared. Back to Zoom 6 in a second. I forgot I changed my x's for this. We don't need all of that. They're going to need to go down a little farther, though, the lines to see the whole thing. Is that what everybody's seeing when they look at your negative 10 to 10 graph? Okay. Anybody go down further in their negatives? I know this thing takes a long time. So did anybody get a number that works pretty good for the cutoff at the bottom yet? Negative 50? So here's my question. Without thinking about the fact that we can't find just how far down these two go, were we accurate? Everything else is right, isn't it? Everything else. That's what just bugs me about not being able to do math at this point. But everything else was accurate. So the one thing we would have to do is we'd have to grab the graphing calculator to figure out this part. Oh, yep, that's really bad. So we could get that in there. The red part I have up there, we just don't know. You know, we'd have to do calculus for that, and we're just not there yet. We're not. So let's look at the next one down here. Oh, they did want us to say how this behaves, and I noticed I didn't write it down. We should put tangent and crosses on here. Said it, just didn't write it down. So they said to describe that part. Forgot it. For it says, what are the zeros of this little monster? What do we do first? Factor in x. What's that? We ask ourselves, could this be a perfect square trinomial? Could this be? This is a could be. We should check this out. This is x squared. This is 2 squared. If you multiply that together and double it, do you get the middle term? It is. It is. That's important. Now, if you're saying to yourself, okay, Cedarholm, I didn't follow the stuff you go through every day. I factored out the GCF, but then I just went to good old-fashioned factoring. I saw it was x minus 2 times x minus 2, and I put it together. That's okay, as long as you recognize, yes, it is something squared, because that's really important for our next step. What are we getting for an answer from this little bugger out here? 0. 0, 0. Multiplicity of just 1, which again we don't typically say, but so that you have something written in your notes, we're going to go ahead and put M1. Tangent or crossing? Crossing. What information are we getting from x minus 2 squared? 2, 0. Multiplicity means tangent. It's a bouncer. It's a bouncer. So let's get on here what we know. We know 0, 0. We know 2, 0. We look back at it and see, oh, this was a cubic, and it was a positive leading coefficient. So we get this little sketch in our head, and we know this is going to happen, and this is going to happen. And then we look at this and say, well, at 0, it's supposed to cross, and at 2, 0, it's supposed to be tangent. So it has to do something like this. I don't know how high it's going to go, but I know it has to do something like that. Punch it into your graphic calculator. Take a peek. Is it doing this minus the dashed thing? It is, right? We got it way too high. So let's find that one spot this time so everybody gets a little practice. In fact, you guys do that. Find me the local max. So everybody gets a little practice at that. Local max of blank at blank. Anybody get it yet? Remember, we're looking for the top of that hill. What'd you get? 1.2 at 0.27. Everybody agree? Oh, I'm sorry. 1.67?
No, 0.67.
Okay, go again, Ashley. Let me write it down. Local max of 1.2.
At about 0.67.
So about 0.7 or so. Everybody getting that? Okay. So we know too high here. So the blue part, gotta trust the calculator for. Just do have to trust the calculator for that piece. Everything else, though, we know. That's so cool. Don't you think that's cool? That I could write any polynomial up here now and you're going to look at it totally differently than you did 4 days ago? I think that's awesome. That is awesome. All right, now, the part that seemed to be bugging people, like I said, we're going to revisit again, and that's our local min and local max. And some books, like this one, will refer to it as relative min and relative max, but it means the same thing. And that's because, pretty obviously, this is not the highest point of this graph. This arrow over here is telling us this is going to go forever. But if we just look at this spot, where it's local, when you say local, you mean right around you, like our town, Elk River. You're local in Elk River. So this piece right here, that is the maximum of that piece. And over here, if we just look at this region of the graph, this is the lowest spot. So that's the local minimum. And those are things that right now we have to trust the calculator to give us. So identifying a relative maximum and minimum is calculator stuff. That's what it is. So let's go ahead and get problem 5 into that good old calculator there. Got ourselves a cubic. So x to the third plus 3x squared. 24x. Oh, it didn't take the x. Or everything. X. Zoom 6. We can't see them. Blinky can't find them. So we're going to need to go up quite a bit and down quite a bit. That's our y's. It has nothing to do with the x's. That's our y's. Anybody find a good Y-min and Y-max yet? Because yours work a lot faster than this thing does. Okay, so negative 50. Oh, so if you go a little bit, oh, let's try negative 40 and split the difference, huh? About 85 or so. We can see it, like you can find it. That's what we need. So we need our local max, which would be right here, and our local min, that would be right there. Again, do this up. No, let's do it this way. 43210 me on how you feel about using the calculator to find this at this point. I'm assuming that people are not having much trouble finding it. Oh, there's still a couple low numbers. All right, so I will do this one. So second trace number 3, and it'll take a while to get Blinky, but Blinky's going to have to be on the left side of that hill. He has to be coming down. And then I'll press enter. And then I have to move Blinky back to the right side of the hill, and again, he has to be coming down. You can't get him right on the top, it won't work. It's looking for a sign change. Enter, and enter through guess. So that one, we have a local min of 47.5. Or local max, sorry, of 47.5 at x equals negative 1.8.
Wait, is that the max?
Oh, great. Did it not punch something in that I thought was in there? It really doesn't like working when all the other stuff is working, so it might be having an issue. X cubed plus 3x squared minus 24x. And graph, second trace, number 4. I'm ready to grab my one that works on the TV. Oh, there it is. Now it's right. $80 at negative 4 about? Are we getting short on time again today? Ah, darn it. Well, there's no going over the test today though. So, we'll finish this up tomorrow, and I'm not going to use the smartboard calculator tomorrow. Hopefully, anybody that needed that, it's done anyway. Just slows everything down so much. So, there's going to be a word problem you won't be able to do. the bell rings on me, just know this, you won't be able to finish this, there'll be a word problem or two that you won't be able to do. Just do what you can. You won't be able probably to do 43 and 45. I might be able to do 45. But do what you can, do everything else so that you just got some last second stuff once we do the word problem piece tomorrow. Thanks for hanging